Hi everyone, thank you for watching this tutorial. In this tutorial, I will show you how to build a custom data servers and realize data on Nucleome Browser. For this tutorial, the data we used is a single-cell high-speed data. You can follow this tutorial by downloading this data from the GEO and pre-process this data into the dataset that can be hosted for our data servers and realized on the Nucleome browser. If you do not want to do those pre-processing steps, we also provide a demo data in this repo, but you can directly use this demo data set to start the data servers and realize those demo tracks on the Nucleome browser. So here I will skip these processing steps and directly go to the session 6, which is starting data servers using the demo data. You can copy these links and I will put the link in the description box of this video, and you can copy it and open it into a web browser. We recommend you to use Google Chrome, which is best to realize Nucleome browser. So here we go. In the first step, we need to clone this repo into our computer. So I click the copy here. On the right, I have already opened the terminal on my computer. So here in the section of requirement, it lists like different tools to process the single cell high-speed data depending on the machine types. Most of those tools should be already installed in your computer. And for directly try this demo dataset, the only thing we need to install is Nucleome server, which is a data server tool that hosts the genomic data. So here I will clone this use git clone. This will download the repo into my local computer, and I can go to this folders. So as you can see, this is the same structure as we see on the GitHub repo. Next, we need to install the Nucleome server. Here I need to decide the machine type. So here I provide a hint of how to decide the machine type and download the right version of Nucleome server. I copy and paste. It says that my machine type is this. So to download the right version, you click this link. Here it shows the recent release of the Nucleome server. So here the latest one is this version, and the 1.26. And so here x86 is same as AMD 64. So I should download this one. I copy this and use wget to download this. And then I use tar to compress this. So here, I put the Nucleome server under the scripts folder. So, and then I also need to go to the section 6 here. And then I also need to make the Nucleome server executable using this command. So, then I can try to see if we can see the help information of the Nucleome server. And then what we need is we need to change the configuration file to match the current path of the folder, and use that folder to in the configuration file. So here I need to use this pwd command. This here is the current complete path of the folder that hosted the repo I just downloaded. And then I can go to this download folder, and in the demo data, in this single cell demo Excel file, I click it, and then we can see this Excel files. So here I will briefly introduce what different sheets mean. So the first sheet in this Excel file is very important. It's called configure. It actually tells us what is the root path of the data. So so all the different data sets should be under this path. So in this example, I already used the pw command to get this path here. It shows exactly the same in the configuration file, but we can also copy paste it just to make sure that it's the right path. And then in the index sheet, it says that there are how many different data sheets that we have. So usually I put the data from the same experiment as the one data sheet. For example, in the first data sheet, it includes all the high C data for this single cell high C experiment or data set. And I have a second data set which include all the ChIP-seq tracks. And the first column is the genome. So here is mouse data set in MM10 genome assembly. And the name is the data sheet that we were created. So here one is called high C and another is called ChIP-seq. And the third column is used for future development. You can just type track here. And the column D here is column ID that associated with the short labels of the track. And the E are the other information I will introduce here quickly what this means. So let's take the first high C sheet as an example. So here, if we go to that sheet, so remember that the column A should be the short labels of the track. So here, the column A are different labels of each track. So here we have a population high C and 8 single cell high C, and these are their labels. And then the other 3 columns, which are B, C, D, represent the URI, this relative links of the data to the root path that we have put into the configure sheet. So for example, in this example here, we can see that in this home folder of the repos, if we see what's included in the demo data folder, it has 3 subfolders, one called 3D, which include all the 3D genome structure files, one called HiC, which include all the demo files for the HiC. So here we have 8 single cell HiC and the population HiC, and another is called ChIP-seq, which include all the ChIP-seq peaks. Therefore, so here, this URI means the relative path to the home folders that we put in the configure sheet. And the meta link here, we just put none here. If you have a URL of tracks that you want to link the track to some web page, we can put it here. And the long label is a longer version of the label, but for this demo, we just use the same label as a short label for each tracks. And this settings is similar in another datasheet called ChIP-seq. As you can see, column A is short label, column B is at the path of each file relative to the root of the home folder, and the column C is meta link, and D is the long label of the tracks. So here we have actually prepared all this. I think for your when you try this, the only thing you need to change are the configure sheet, the column B2 here. you can use the pwd command to determine what are the home folders of the repo you just downloaded. And then we can start our genomic service using this command. We can just copy it. Oh, it is some errors showing that it cannot read some files. We need to figure out why. Oh, I know. I think I didn't save it. Let's try to save it. Yes, now it's correct. Don't forget to save the Excel configuration files. Otherwise, or you will be confused. Okay. Now we have successfully started data servers for the genomic data. And also in the demo dataset, in the demo dataset folder, we noticed there's a 3D genome structure demo data. So we can also go to that. So here I also go to the folders of the repo we just download into our computer. And in this demo data folder, there's a 3D. And we need to start another data service to host those 3D genome structure models. We can use this command. So here, notice that by default, the genomic data we use the port 8611, and we need to use another port. So here, I give arguments port here and assign it to a different port. And the root here is the folders that host the 3D genome structures. As you can see that the 3D structures is hosted it's located under the demo data folder and the 3D subfolder. So I put it here and just click enter. And okay, it seems like the data service is already successfully started. Next, so we actually finished all the configuration part. We can open a web browser in the Chrome or Safari browser and go to this link. So, and then this is the home page of the Nucleome Browser. If we click Start, and you can try some public sessions or quick start for him and the mouse. And here we can just start a new window of the Nucleome Browser. If we use the default port for the genomic data, which should be 8611, this data servers will automatically load. We can double check this. Let's go to the smaller video. Okay. So don't forget to select the right genome assembly. So here we choose MM10. And we can select different data sheets using this drop-down menus. And all those different data sheets are the 40M public data that we have hosted on our server. But at the end, we can see that there's two more data sets that belong to our custom data, one called IC. Okay, we can just click it, and we can click the check mark to add this to the genome browser. Okay, and we can after we add this one, we can click this button to see that. Go to region and change it to dense. And because this is a demo data set, we actually only include data from a smaller content, which comes in 90. The smallest one in the mouse. So don't be surprised that you see the tracks keep loading, because this is some small demo this that makes sense. It's only equal to one chromosome data. But for the chromosome 19, they have all the data there. So here, the first track are the population HiC, and I also included two single cell HiC data here. So we can make it larger so we can do some fancy stuff here. Next, we can remove those black lines and we can duplicate this. And if you found that the custom data server is not automatically load on the Nucleome browser, you can also manually load it. To do that, I also have figure here shows you how to do that. You can click this button here and this configuration button, and then click this setting button to add a custom data server. Let's try this. And click the refresh button. When it says active, this means that you have automatically load the custom server. But usually you do not need to do that because it should automatically load that if you use the default port number. And then we can also add the public 40N1 by typing /d/portal. And we can do the name and the slash. Okay. Now we have added two data servers here. For this Genome Browser panel, we do not want to show the HiC, but instead we want to show the chipset data. Here we click this button, we'll add all the chipset data in this datasheet. And if we click go, it will load this. Notice that by default, the pig will be in the for mode because we show the whole chromosome, which seems quite uncomfortable to realize that we can use this button here to simultaneously make all the track, change it into the dense mode. And then we can do some fancy things here. So for example, here, if we want to highlight a region in the single cell HiC content maps, we can simultaneously highlight other regions even across different panels. And we can move it and to see that this is very helpful if we want to compare, for example, across different cell lines or different conditions, and compare the genomic data, like compare HiC with genomic data. And don't forget that we also add 3D genome structure models with the service. In this, I think in this terminal, yes. So what we can do is that we can use click this add panel button and click the chromosome 3D panel. So here, by default, it will add demo or 3D files. We can rearrange the panel so that you can see all the different panels. And then in this tutorial, it tells me that to build the 3D genome structure models, I can go to this link. I can copy it here. Okay, so for this demo data, we have prepared 10 models for each cell, cell 1 and cell 2. And for example, if we want to see this one, we can click copy the link and go back to the Nucleome browser and paste the link of the model in the structure URL box and click enter. Load it. Oh, sorry. There's some we need to don't forget the that. Yes. So here we can see that this is model 4 for cell 1. And let's add another. Let's first drag it here. And so we have genomic tracks on the left and 3D structures on the right. We can duplicate these panels and rearrange it into top bottom settings. So here, let's try another one. I think we can try a cell 2, depend on model 4, and then so now we have load 2 different models. The top one is for cell 1, and the bottom one is for cell 2. Since these are 2 different cells, we do not want to like move one structure and the other one automatically move. We probably want to have controls for individual structures. We can put a different channel here, communication channels or simply channels, whatever. So basically, if we assign the different channel ID for them, actually we can independently control them. So next, we want to add some interactive functions to the 3D structures. We click this button, and so it will not show all the chromosomes for the genome, but also show some fancy stuff. So I will show you quickly. So we can click the rightmost button here, which means that only the highlighted regions on the other panels, for example, in the Nucleome Browser panels on the left will be highlighted. Okay, finally it shows this. So if we can use the trackpad or mouse to zoom in to see these different structures. Okay, so here's we can actually highlight on the Nucleome Browser panels on the left and realize these highlighted regions on the right. Okay. This is very useful tools actually to compare the genomic data with 3D structures. So let's do some experiments to see like if the differences we see on the single cell high-seq contact actually match the 3D genome structures. So so here this region might be interesting because it shows that it has this, some single cell high series for the cell 2 in this region, but it didn't show in the cell 1. However, interestingly, because for each cell we have different models, but in this model actually we see opposite things. Maybe if we try to load another model, it will be different. We try the load the model 5 for cell 2. Okay, this one is also some, yeah. But as you can see, this is helpful to just to compare the 3D with the genomic data. And another fancy thing of this that we can superimpose big wig tracks onto the 3D. Let me show you how to do that. To do that, let's we need to load big wig tracks. For example, let's try to load the DAM-ID tracks here. If you click this button, it will show what this means. This may not be for the same cell line, but we can just show that for this purpose. Just for realization, and we can also try to load maybe the timing. Okay, and then we can click. Let's first show the original block to support. Okay, and click this button. So by default, it means that the colors of the chromosome is determined by the chromosome IDs. But if we click this button, a box will show up here so that we can drop big wig tracks here. So we can, for example, drag the gamma tracks and drop it here. Wait a few seconds. Okay. So now the chromosome is colored by the gamma ID signals. It may look not interesting. It looks like the red and green is high and low of the gamma ID, but again, this is not for the same cell type. So this is not for the same data as used for demo. We are purpose here. And we can also drag the replication time here. Wait a few seconds. Oh, okay, looks like this data has not plus and minus values, but rather some run to check. But yes, this is what you can do, like superimpose the weak checks onto the 3D structures. And let's do some and do other things. So for example, now we can close the 3D panels. And we can compare multiple replication timing data. Maybe we should compare gamma. Let's compare gamma. I load 3 gamma ID tracks here, so I can see here. And then we can use this button to open an interactive scatterplot analysis tool. Click this button. We can select which are the x and y axis. Here, x-axis is y-axis that. Okay, looks from eyeballing the first track and second track are quite similar, and this Scatterplot tools actually confirm the result from eyeballing, and then we can actually highlight on the tracks. And those highlighted genome rings will be also highlighted on the Scatterplot. And this operation is also reciprocal, meaning that if we circle some regions on the Scatterplot tool, for example, if we can circle the ones that both has very negative values for these two tracks and see what's happening. But luckily, the Nucleome Browser automatically sees the sessions, so you can click load the last sessions. Okay. Here you can close the 3D panels. We can actually hide this IC because it uses a lot of resources to display them. Okay. Let's read. That might be okay. Okay. Now, Scatterplot to. Okay, now if we circle some points on the Scatterplot view, we should see those highlighted regions on the genomic tracks on the left. Oh yes, so as I said before, the highlighted regions that both have very low signals for the both two tracks, and indeed those regions are highlighted as shown here. They actually highlight a lot of genomic things. And so basically that's pretty much of the tutorial itself. And you can also go to the home page of the Nucleome Browser to we have some we have more examples, the sessions that you can try, and also some image data demos here. And there's also documentations that you can explore to use different types of panels, and also the plugins that you can connect into browser with custom web applications and other web portals like UCIC, Gmail Browser, and Virtual Gmail Browser. And then, yeah, thank you. I think that's pretty much of this tutorial.